Hello, this is Mrs. Koch for another wonderful year of Math 8 Notes. And this year we are starting with rational and irrational numbers. So let's see. Next. Okay, so we classify numbers just like we classify plants and animals. There's a hierarchical system, which means that there's a bigger classification called the real numbers that all the numbers you're going to learn about this year fall into. And then it breaks down into rational and irrational, and then there's subcategories within those too. So this is a cute video titled Pre-Algebra 32 on irrational numbers. Since it's not my video, I will let you look it up and see it on your own. It tells the story of how irrational numbers can get you killed. And basically, the ancient Greeks love rational numbers. They believed that every number could be written as a ratio, and this made them very happy. And then they discovered that the square root of 2 could not be written as a ratio. And the mathematician group that discovered this was told not to let this secret be known. The guy who did talk about the fact that there were numbers that couldn't be written as ratios or fractions was killed. So our first number classification that we know about are the natural numbers. These are numbers that you naturally learned. 1, 2, 3. They're also known as the counting numbers, natural numbers or counting numbers. Now, you can throw in just one more number, the number 0, and that is called the whole numbers. So when you include 0, like a big circle or whole, you call it the whole numbers. Then in 7th grade, you spent a lot of time with integer operations. These are the whole numbers, including all the negatives. So 1, 2, 3, plus 0, plus -1, -2, and -3. And then we have rational numbers. Rational numbers are going to be a big focus this year. We're going to be doing equations with rational numbers. And right now we're learning about different types of rational numbers. So rational numbers, the definition is any number that can be written as a ratio. Now remember, a ratio can be expressed as a fraction. So we've got our fractions. Then any fraction can also be changed into decimal form. And if it is a fraction, there's two different kinds of decimals it might be. It might be a terminating decimal. These are our decimals that have maybe 1 digit, 2 digits, 3 digits, but they stop at a certain point, like 0.5 or 0.32 or 0.125. There's also repeating decimals, and these are indicated with a little bar or line on top of the numbers that repeat. Repeating decimals are also able to be written in fraction form. They don't terminate or stop after a certain number of digits like terminating decimals do, but they're still rational numbers. Okay, now here's our new classification for 8th grade. They are irrational numbers because means not. Irrational numbers are numbers that cannot be written as fractions. That means when you write them out as decimals, they do not terminate and they do not repeat. So they are numbers that go on and on forever in their decimal expansion with no repeating pattern. Let's see what's here. A good example of these would be any square root of a number that isn't a perfect square. For example, the Greeks discovered irrational numbers by considering the square root of 2, because there isn't any integer that you can multiply by itself and get 2, because 1 times 1 is 1, and 2 times 2 is 4. So there isn't a way to get 2. So if you look at the square root of 2, that is irrational. So would the square root of 3 be? But the square root of 4, that is rational because the square root of 4 is 2. Another category of numbers that are irrational are any number that has pi in it. So like 2 times pi, pi to the 5th power, 5 pi minus 3. Anything with pi in it is going to be irrational. And you should have already learned that pi is often represented by 3.14 or 7 over 22 sevenths. But those are approximations. Pi goes on and on forever with no pattern. Okay, so here's a little practice. -12, is that rational or irrational? Well, -12 is an integer, and you can write it as a fraction, -12 over 1. So that's rational because integers are part of the rational numbers. How about pi? What we just said, pi goes on and on forever without any pattern. So that makes it irrational. Its decimal form is non-terminating and it's non-repeating. Okay, so in class, you're going to work through a longer list. But for now, let's look at a couple more. 0.6. Well, 0.6 is a decimal. So you can rewrite it as the proper way of reading 0.6 is 6/10. And 6/10 is a fraction that reduces to 3/5. 7/8. Well, 7/8 is already in fraction form, so that's very easy to see that that is a rational number. And then in class, you're going to try some word problems. Okay, well, that's it for today. Hope that helped you understand the difference between rational and irrational numbers.